Welcome to the 7th lab session of Computer Networks. In previous labs, we covered the TCP Echo Client and TCP Echo Server for both the TCP and UDP. We also covered the details about the TCP and the UDP, and we also saw when we send a message to the server how it is reflected back in the form of echo. So I will just briefly go through a quick review for the TCP Echo Client and the UDP Echo Client and servers, and then I'll come back to today's lab. So as always, you have to go to the this directory, cygwn home and your usernames. Let me have a brief review to first the TCP side and then the UDP side. So the TCP, I think I don't have to go through all the details. When the connection was established, then we were writing a message towards the server. So when the TCP was receiving that message from the client side, it was reading it from the client and then it was writing it back towards the client. And then when the client TCP echo was receiving that message from the server, then it was simply printing it, and we could see that message that we had sent from the client side. So the message was bouncing back from the server. And the same way, almost the same concept was there in the UDP also. We were, instead of reading and writing, since it was a connectionless, there was no connection. So for each message, we were using the send to and receive from. When we were using send to, then we were also defining the destination address of the server, and we were sending the message from the buffer. And when we were receiving from, again we had to specify the address of the destination, and then we were getting the message in our buffer, and finally we were printing it out. So for the UDP client and UDP server, I had shown you in the previous lab that the in server the receive from operation is first. Why? Because in the UDP client the send to was earlier than the receive from. So firstly the client will send any message sent to with the destination address, and then the server will receive it using the receive from. It will read that message from the client address, but it will not use the write command because there is no connection established. So it will simply use the send to by using the client address, and finally the client will receive it here, and while receiving it, it will use the other command which is receive from, and it will just buffer the message coming from the server back, and it will finally print it out. So the main difference in the TCP side was we could not send the concurrent messages from different terminals, or which means that at a time when the connection was established between a client and a server and other terminal through which we were trying to make a connection with the server, it was not possible in the form of TCP until and unless the previous terminal was finished, or that terminal was cancelled, or we were pressing Q from the previous terminal, and it was working as like sequentially. Like at a time one client is connected, once that connection is over, then as the next connection was starting, and up to 5 connections the TCP connection was able to establish. On the other hand, in the UDP, since there was no connection establishment, so anytime when this client was trying to reach the server, it was simply writing the SOC address of the server side, and instantly from any amount of terminals, it could send a message to the UDP server side. So that was the main difference between the UDP and the TCP. UDP was connectionless and the TCP was connection oriented. And to make a connection from a TCP, there was a three-way handshake technique that we had seen in detail in the previous lab. In the previous example, we also saw two hosts. We call one of the host is host 1 and the other is host 2. So the host 2 was sending a message, and each message was differently defined, and then each message was sent like in the form of send to using the socket address of the host 1. And when the host 1 was receiving it, host 1 was creating a delay for 5 seconds, and each time it was receiving a message, it was displaying the message from the client, and then again for the next iteration there was a delay again for the 5 seconds. We were sending some message, and the message 1 is hi, and message 2 is I'm another UDP host, and the message 3 is nice to meet you, and then they were sent back to back. Here you can see it that there was not any delay from the client side, but they were sent back to back. but when it was received at the other side or on the host one, it was, since receiving it concurrently one after the other, but when it was receiving there was a delay. So if you remove just this delay from here, it will just instantly get all the three messages. But since because of this delay, it was first receiving this message from the client, and then there was the 5 second delay, then there was the next iteration, and then the next message was I'm another UDP host, and then again there was next iteration and delay, and after that then there was nice to meet you message. So this was all we saw for the UDP examples, and today's lab we will be covering remote data processing. It is very important. I will just explain you in a while, and then I will also explain you what is the concepts of header, and then I will explain you what is the difference between the TCP header and the UDP header, how the overhead of the TCP is more than the overhead of the UDP. So let us start. So you may have heard of IoTs, Internet of Things, or any data coming from wireless sensor networks. What is happening there? The data from the remote devices, for example, there is a temperature sensor, GPS or accelerometer, light sensor, proximity sensors, different type of sensors are there. So any data coming from there, it is given to the application, and then the application is sending all the data to a remote server. Then there is a remote server which is processing the data coming from sensor, and it will calculate the status of the data, and whatever the processing is needed, it is done by this server or in the cloud. Once this processing is done here at the server, it will send the result back towards this each client where it is desired. However, this is quite a complicated example, and for this you will need a lot of sensors, and then you have to define port for your application, and then you have to acquire the data from each and every sensor, and then you have to transfer it to the destination server for further processing. But we will do something like that in today's example. So we will be doing kind of remote data processing using a client and server, and we will be feeding the number of operand. So for example, you are going to make operation on 2 operands, 3 operands, 4 operands. Operands means 3 plus 4. Here the 3 and 4 both are operands, and the plus is the operator, are 5 multiplied by 3 multiplied by 4. Here the 5, 3 and 4, they are the operands, and the multiplication is the operator. So how much operands do you want to operate on? Here the firstly you will give either 4, 5 or whatever the number is. It will be saved as the first position and the first position of your buffer, and then it will take the input from the user, and each time the user will be entering some integer value, and that integer value will be saved in the consecutive location of the buffers. And after that, the last thing it will ask for the what kind of operation you use. Since we have defined that we have this much number of operands, so it will definitely know that after, for example, you are feeding 5 operands which was defined here, then the next thing should be operator. So the last thing which will be saved in this buffer will be operator, and then the operator is also fed here. Then all this raw data is transmitted to the server side. The server will calculate the data based on the information coming from here. So the server will know there are, for instance, 5 operands, and the operation to be made is plus or addition. So it will make an addition operation, or it can be division, or it can be multiplication, or whatever. So that kind of process is performed here, and once the data is processed, all the processed info will be retransmitted back towards the buffer, and from the buffer we can acquire our result, and finally the client can see that result. So let us see this example, and using the notion of this example you can then make it more enhanced, and I hope in future you will be able to do something like that. You can use a smartphone. In smartphone you have lot of sensors. You have accelerometer there, you have GPS there, you have magnetic sensor there, you have light sensor there, and you have image sensor like camera, microphone and gyroscope. etc., etc. And mostly all these sensors in your smartphone, you can get the sensor data from the user, or sometimes from the smartwatch, which also can get such kind of even the heart activity, the number of heart beats from your pulses that can estimate. All those data you can get from your smartwatch or from your mobile, and then that data can be transferred to a server. And after monitoring all this kind of data, the health status of that particular person can be known. So let us see how this remote data processing example works. I think I should delete all the unnecessary data from here. Let me rename it as op underscore client operation client, and also this one is operational server opserver. I will start with the client first. I need all this, so I will keep it like this. Again, I need a buffer, so I will also keep it like this. And then I need a socket, so of course I should keep it like this. And I think I should just change this one to the operation message, for example. So opmsg in short, I will write it like that so that we cannot conflict it with some other thing. And then I will also just I need two variables, right? So for the storing the result, and also I need a variable which can count my operation. So let me call it operand count. And then for a loop I will also declare I and then I should have a socket n, and also I should have a server address. Again, I should check the arguments, and if it is not equal to the three arguments, then it should give me this such kind of error and it should exit. And I'm going to define a socket which is TCP socket. I'll keep it as it is, and if the socket fd is -1, then it should give me an error handling, and I've already defined the error handling there, so I should not be worried about this one. And then we have the bounding parameters, and then there is the connection establishment with the server address, and if there is no connection, then it should give me the handling error. Now here are some important lines, and I should just write it here. So let me give it fewer enter so that I can delete it later and if they are not required. So here I'm going to ask from the user to give me the operand count, and the user will just specify the number of counts that we want to make. For example, we are making the operation are 5 numbers or 4 numbers or 3 integers. So here the user will just enter the specific amount, the specific number of operations that has to be performed on operands. Get the value from the user and save it into the operand count. Now we know that how much the operand count we have, so we can simply write a for loop here. I can specify here that I have this much of operands, and then I can get the value from the user. But inside that, initially I also have to define the number of operand at the initial index, so I can do it like that. And then I can put the proceeding value here by giving it some offset. And for offset, I will define a variable here, and I can use that variable here, +1. After that, I can get the input from the user. After that, I can get a character from the user that what kind of operation should be performed on the operands which I defined here. So if I have defined 5 operand count, and then I have given 5 integer values here, then here I have to define that what kind of operation should be performed there. Is it plus, minus, division, or whatever it is? So I will get it from the user using this. and the user will provide the value of that operator by using the scanf, and the scanf can get it in the form of the character, which we will define it here as %c, and save it in the same buffer. Now this means that save it and the last one. So what's happening here? Firstly, we defined that we need, for instance, buffer of we need like to put to make operation of 5 operands, right? So here this will run for 5, for example, and then it will keep incrementing here, and the buffer, the op, this one buffer will contain values like this, like we have the 5 operands there, and the first operand, any user value, for example the user put 2, so it will come as 2, then 4, then 7, and then random number like 5. So and then again 1, so the user put the values, input the values as 2, 4, 7, 5, 1. So this will be saved here, but we also need to know about the type of operation that has to be performed in the last 5 digit, which was predicted by this operand count. So this offset is also equal to that offset, so the operand count is multiplied with that size that we just defined there, which was 4, and then after that there will be another value saved here. So this function basically saves the value like the initial 5, and then 2, 4, 7, 5, 1, and then the last value has to be saved in the form of character. So it will be saved like if you put the plus, so it will be saved as plus, or if you put division, so it will be saved as that, or minus, or whatever, so it will be saved like that, right? So I hope it is clear. So let me delete it because it's not necessary to be shown here. And now we can just transmit it towards the server. What has to be transmitted? Anything that is in the our open message, operation message, anything that is in our operation message. And what is the size? So instead of this much, we should just put a little more than that. Once it is transmitted to the server makes the operations, then we will be getting some response from the server, right? So that response we can read from there, and that we can again get from the socket that is created towards the server, and any result, the result we declared here. That's why we declared the result here. And I think I should also define one more thing here. And I will call it the result size. And finally, I'll just print it out. So that is it, and I will just delete everything. Finally, we have used the error handling, so we will keep it as it is. So I think this is enough for the client side, and now we will define also for the server. So I saved it, and let's go towards the server and make the corresponding changes. It would be better if we just copy everything from here and just paste it, and then make some changes in the client side to make it a server, because we have to do then everything from these things again, so we don't want to do that. So to make the server, let's go and do it in step by step. So I'll need not only sock, but I'll need two. One is the server address, one is the server sock, and the other is the client sock. So instead of the operation message, because the operation message was from the client side, I will call it the operation info, and let's keep the buffer size same as before. And then I also have these operands which are still required, and here we not only require the server address but we also require the client address. Finally, in the variable declaration we also need the client address size, so I will just simply define it as client address size. The server, it doesn't contain this thing, so we will simply delete it, and we need only 2, so I will put it 2. We don't need IP. Server underscore suck. So the server underscore server file descriptor will be defined here, and it will do the same thing which we did earlier. And if there is any error, then go to the error handling. Otherwise, just define the structure for the server socket. Instead of connect here, we should put the bind, and here we should get the server underscore suck. So if there is any error in the server binding, then it should give us the bind error. And then we also listening at the server, right? So and after we are done with the listening and everything is going well, then we will just get the client address size, and we have declared a variable for that, which is client address size, just here. So we have declared already the variable for that one, and we can just simply call it size of. Now, since the server can listen up to 5 accepted clients, so I will just simply put it 5. I'll initialize the operand code at 0, and then I'll accept the client. This is not communication, this is accept. If there is any request coming from the server. If there is any request coming from the client. So the client socket can be acquired as accepting the connection request from there. So here is our client socket file descriptor, and I will just simply accept it. And after accepting it, I will have all the information for the client here, the client port and also the client IP and everything. Here you can also do the error handling. If there is this is equal to -1, the file descriptor is -1, then it means that there is no client accepted here and it should be an error. But let's skip that one and just simply read it. We assume that it has been accepted. From the client side, it will initial the value coming from there, and it will read the first one, and which contains actually the operand count, and it will come to know what the operand count is there. And once we know the operand count, then we can just proceed, and up to that one size we can receive any amount of the operand that should be acted upon, and then we can perform the operation there. Here I should also declare the receive count and the receive length. The receive length and also the receive count. Now keep receiving the number of operand until we exceeding this operation count limit, and once we receive all the operand and then perform the operation. So while is monitoring the maximum bound, the maximum limit. So while is monitoring the maximum limit of the operation count that is coming inside the buffer, then each time it is reading here, it is saved in the receive count, and then it is also added in the receive length. And if this is exceeding the receive length, then it means that the condition is false, and then at this stage we have all the values from the client side. The initial, for example, I think it was 5, then we had some, for example, 5 operands, and then we had some operation, for example, plus or minus or anything. Now at this stage we are going to define a function here, so I think I should delete this one. I don't need it anymore. I'm calling that as a calculation function, and this calculations should take the operand count, how much operation I have, and then I also need to give all values of the operand and the integer cost, and finally the operation to be performed. Now I have to declare it here at the beginning, and I also have to define it. So I'll simply say that it is integer, the first one, and it is how much number of operation we have. So I'll just call it operation number, and then the other one is the array. So I can take it as in the form of integer array, and I can call it operand. So OPNDS, and that is in the form of array, so we don't know how much it is. And finally the final thing is character that we had feeded in the client side, and I'll call it char and operator. And now let's define this function. I'll say that the result is equal to, let's make it as a switch statement, and the switch is basically the operation, and the operation is coming from the client, so whatever the operation is, just perform it here, and then we will just define the cases here. So I think this is pretty easy, and it's the same as calculator function. So you are already familiar how to do this. If any operand, the last one thing, if it is plus or minus or anything there, so go for all the search for all the operands and perform that operation with that. I'll simply copy and paste these operations for the subtraction, and also for the multiplication, for the division and everything, so you can do it for all. So if it is subtraction, then it should be minus, and if it is multiplication, then it should be multiplied. That's it. And finally, return the result. So our function is created already, and yeah, I should define it in the form of integer because it is going to return an integer value for us. Now coming back to the program, and then just whatever the result we get from the calculation, write it towards the client. And after that, close the client socket. And then delete everything which is not necessary now, and then close the sock server. I hope this is fine and everything is complete. So I will save this one and also this one, and let's run the program now. Now let us test the server and the client. So this is our server, we call it the server OP, and the other one we call this a client OP. So I hope there is no error, and finally we have the server OP and the client OP here. Now I'm running the server first, and let's say I'm not running the server and I'm just doing it for the client op.exe, and then I say 127.0.0.1, and let me define 3333. Okay, this is the port address. Since I haven't opened the server, and if I enter it, it will not do anything because there is a connection error. There is no server established here. So before that, I should have the server started. So I will start the server, and let's say the port address is that one, and then I will allow access. Yes, allow access. Okay. And now once I do that, so it's the connection is established, it is connected, and for instance I am making operation on 4, so operation count is 4, and now the first operand I say 3 enter, 6 enter, 8 enter, and 3 enter. And what is the operator? So operator, I will say, let's say the operator is plus. So 3 plus 8 plus 3 plus 11, 11 plus 3, 14, 14 plus 6 is equal to 20. So our result is 20. And if I do it again, I'm making operations on 5, and the first operand is 3, then 6, then 4, then 8, and then 3 again, and then I say the operation is minus, so it's minus 18. So it will just 3 minus 6 minus 4 minus 8 minus 3, and finally it will do the operations. And for the multiplication, let's say I should say 4, and I should say 3 3 3 3, and I think it should be, yeah, 81. 3 multiplied by 3 multiplied by 3 multiplied by 3. That's it. Um, if I say, uh, let's say I make a connection, I say there are 4 count, and here I cancel this server, and I say that this is operation number 3, operation number uh, operator number 5, operator number 6, 3 number sorry, operator 1 takes the data 3, 5, 6, and 7, then the operation result is 0. Why? Because here the server is off, so I don't have any server there that can do the process for here. So it will take the data from here, it will send it to the server will process the data, and it will then send it back to the client, and then we can see the result. So the both has to be turned on. The server has to be on, and it should be responding to anything coming from the client, processing it, and then giving it back towards the client. So the example that was, I hope, pretty clear. And then we have the concept of header, which is the next title. So the data, or we call it the payload in the networks. So it can be generated by several applications, like you are browsing, for example, web page. So that can be HTTP, or you are using Dropbox or something FTP, or Telnet STMP and SSH, and different types of applications layers are there. So any application, depending upon what kind of application it is, it will be using some different types of protocol, and then it generates some traffic. That traffic we call data. That data, when goes towards the transportation layer, a header is added to it. The header means that what is the required field for this data to be further processed, what is the source port and what is the destination port, and what is the sequence number of this data, and what kind of flags to be carried with this data. So anything that is important, and are you going to take this data towards the destination is in the form of UDP, or you want to take it in the form of TCP. All those information are added here with the first header, and then it is forwarded to the next layer. And the next layer, since this header is already here, then another header is added there that we have seen in couple of back labs. That header contains the IP address, the source IP from where you are going, and the destination of IP to where you are going. And then it is going to the MAC layer, data link layer, and in data link layer again another header is added, which also puts some MAC addresses for information, source MAC and all those things. So all those informations are added, and every time it is passing from one layer to the other layer, each layer is putting its own information in the form of header. So once it goes to the physical layer, it will transmit it over the link, and finally it will receive there. And at the destination, then from physical it will given to the data link layer. The data link will read that one, and then it will skip it, and then it will given to the IP layer or the network layer. The network layer will see the what is the destination IP here, and then it will delete this part and give it to the transport layer. The transport layer will see the source port, destination port, and all those information and the sequence number, and then it will give it to the designated application. So that designation application will extract the payload from there, and it will process it accordingly. So if we look at the TCP header and the UDP header, they are quite different. The TCP header, since it is reliable communication, so it has to take care of a lot of things, whether your data is transported securely or not securely. This TCP header has 20 octets or 20 bytes here, but there are some optional other further 40 bytes here. So in total, it is ranging from 20 bytes to 60 bytes, the total header length of the TCP. And on the other hand, the UDP is 8 byte of the total length, header length. If we look at the TCP header contains the first thing is the source port, and the next one is the destination port. So if you see this one columns, so it is ranging from 0 to 16 and 16 to 31, which means that this is 2 bytes here and 2 bytes here. So the source port is 2 bytes or 16 bits, and also the destination port is 2 byte or 16 bits. So 16 bits means that it can access up to the ports equal to 2 to the power of 16. So usually from 0 to 1023, they are dedicated ports. Like, dedicated ports means that those ports are already allocated, are well-known ports. For example, uh, uh, SSH will have a port which is predefined. Our TFTP has a port which is predefined, so you cannot reuse those ports. Those ports are already dedicated for those particular applications. And if you have to use any port, you have to start from 1024. So anything from 1024 to the 2 to the power of 16. So I think you should read the math behind this thing, behind the port and the source port or destination port and how to define it. But here it is, the source port length is 2 byte, and also the destination port length is 2 byte. Then you have here the sequence number. So whenever you are transmitting a byte, each byte is the sequence number is incremented with each byte. So for example, whenever you are starting the connection, that will send a sync is always 1 byte, so 1 byte will be incremented with the sequence number 1. The sequence number length is 16 plus 16, so it is 32 bit or 4 byte. The sequence number total length is 4 byte. And when you are sending something, for example, you are starting from the sync is, for example, 1 byte, so the sequence number will be incremented by 1 byte. And when you are transmitting 10 byte of data, so 1 will be added with the 10 bytes, and then it will be keep incrementing. So each byte of data will keep incrementing this sequence number. At the destination, when it read the final byte, so it will be also incremented at byte wise, and then it will just send it towards the sender that the last byte I was this number. Then we have, if you see it, the header length is only 4 bit, but as I said that this one total is up to 60 byte or up to 20 byte. So if it is header length is 4 bit, which means that 2 to the power of 4, 16, which means that it can only have a length of 16. It can have 1111 maximum byte. So how can we have the header length for the whole TCP header? This header length is scale up with 4. So if you are reading, this one is 1111, which means that it is 15, right? So 15 is multiplied always with 4. So 4 multiplied by 15 is equal to 60, which means that it is carrying the whole TCP header. It is occupying all the TCP header. Or if it is some other number, so then it will be multiplied with 4. So each time this header length is multiplied with 4. If it is less than 20 bytes, which is this one, it means that there is something corrupted in the header file and it's not proper. So even in that case, this will be wrong. So at least it should be 20 octets, and at most it should be 60 octets. There is like 6-bit reserved bytes, almost it's like 4, and then there are 2 more bytes, bits, sorry, not bytes. So there are 6 bits reserved which are used for the future purpose, and then there are some flags. Like, the flags can be urgent flags. Sometimes the data is very urgent, then the urgent flag is up, it is 1, and then the data is urgently transmitted. There is acknowledge flag, there is sync flag or finishing flag. So whatever the flag you want to start with, you have to make up that flag, or put the one on that flag, and then you have to send the data. For example, you are initiating a connection. In that case, you have to turn up the sync flag, and the sync flag will be used as the initialization, or the initialization of the connection. And if you want to finish the connection, then you have to turn up the finish flag. The window size means that this is controlling the congestion window, and then you have the checksum. Checksum is used for the error detection. So it is only detecting the error. It's not correcting the error, but it's only for detection the errors. Since the data from the application layer is coming to the transportation layer, or TCP, in the form of streams, and then the TCP divides that streams and segments. So sometimes the segment is not completed and it's keep waiting for the data to come from the application, and that once the segment is completed, then it is transmitted. But the urgent pointer, sometimes the data is urgent, so in that case the data is just simply transmitted. And these are some other additional things reserved for some additional options. On the other hand, the overhead of the UDP is very simple and very small. We have only the source port, which is again the 16 bits or 2 bytes, and then the destination port, which is again 2 bytes. And then we have the what is the length of the segment, and finally there is a checksum. But this checksum is not that much important. Even if you don't provide this checksum, it is fine, because the checksum only identify whether the data has been received correctly or not correctly. So the checksum is only detecting if there is an error, it is not correcting it. So correction is not there. Anyway, the receiver has to receive the data at any cost. So there is no acknowledgement to tell the sender that this data has been corrupted and send it back. So this there is a checksum which is not so mandatory in TCP IP version 4. But yeah, in the recent TCP IP version 6, this is mandatory. So there is always a checksum. Thank you for having your attention. And here I conclude my today's lab session. And I will see you in next lab. Please take care of yourself.